Alright, so today we are going to talk about combinational logic gate. So the combinational logic gate simply involves the combination of several logic gates, okay, which are mostly connected to give an output. So I have an example here, which we have a NOT gate here, we have AND gate, we also have another NOT gate. This is also another NOT gate, and then we have the NOR gate, which is a combination of an OR gate and then a NOT gate. So I told you you can use this symbol here. Okay, you can just connect the OR gate to this NOT gate, or you can still use this small circle here. So we have this, and then the question is that we should provide the truth table for this combinational logic gate. Now we have A to be the first input, and then we have B to be the second output. Then we have our C here. So we have our C here to be the output. Yes. Now the input of A is 0 and 1, and the input of B is 0 and 1. So what happens is that we take these type of questions in the row direction. Okay, so we consider the row direction. So we're going to consider 0 0, and then we consider 1 1. All right, so here, if A is 0, then we have B to be 0. And then for the second set, if A is 1, then we would have B to be 1 as well. Okay, now one thing that we should note is that from right from the input, okay, to the early stage of the output, that whole area is what is known as the intermediate output. So it means that from this area, so from this side, so from here to this side, oh sorry, so from this place to the whole of this area, this whole thing here is the intermediate output, and this is the input, this is the input. So right from the input, we have the intermediate output before you will get to the actual output, or we say the final output. Now if A is 1, okay, let's start from this first set. If A is 0, I would have 0 here, but this is a NOT gate. So over here you have to apply the laws or the principles of each of the gates that we learned. Okay, you will have to apply them so that you get your final result. So if I have 0 to be here, a NOT gate will convert the 0 to 1. Okay, so I'll end up with 1 here. We are dealing with this A being 0. A NOT gate will give us the opposite, okay, which is 1. And then we have 2 input here, but one of the input is connected with the input from B. So what happens is that we have to come back to B, get the results from B here, and then project it to this side before we can move on to this side, because this is two inputs. You have to get the values for this input and that input. So over here now, don't forget we are dealing with this first set. So if A is 0, I still have B to be 0 here. So I start with 0 as B. So this is also a NOT gate where B is also 0. So here becomes 1 as well. Here becomes 1 as well. Now, this one goes in this direction. Okay. But we have, for if you look at this, we have tabbed from B. So this means the same one moving this way would also move this way. Okay, so it would go in two directions, this path and then this path. So this means you would have 1 1. Okay, so 1 1. So the input for this AND gate will be 1 1. And then for AND gate, we said that all input all input should be positive to get a positive output. Okay, and vice versa. So if I have 1 1 here, I will produce 1 here as the output. Okay, don't forget we still have our 1 here. This same one is moving in the same path here. So we have a NOT gate here which acts in the opposite way. So it will convert this one to 0. Yeah, so this one will be changed to 0 by the NOT gate here. Now this is a NOR gate, OR gate, and then NOT gate. So I have 0 as one input and 1 as one input. So over here you have to break this one down. It is a NOR gate and then a NOT gate. So for a NOT gate, all that we have to understand is that the NOT gate acts in the opposite direction to that of every input. Now you have to treat the OR gate first before you treat this NOT gate. So if you look at here, I use this symbol, okay, and then here I also use this symbol, but over here I will just go with this smaller circle here. So what happens is that I have input 0 and then input 1. Let me deal with the OR gate. So for every OR gate, the one of the inputs supposed to be 1. Okay, at least if both are 1 1, that is positive, then we would have a positive output. And then at least when 1 is 0, we would have a positive output. Okay, for the OR gate alone, we would have 1 as our output for the OR gate alone. Okay, so that is 0 1, giving us 1 for the OR gate. And then when it passes through this NOR, so when it passes through this NOT gate, I would get the opposite of this, which is 0. So this makes our output. So this makes our output here 0. So C becomes 0 for the first set. So C becomes 0 for the first set. So you can still go over it so that you get every understanding that you want. And then you solve more examples on different input. Okay. Yeah, so let's consider the second set. So we are always dealing in the row direction. Yes. So let's consider the second set. We have A to be 1, and then we have our B to be 1. So this a NOT gate, it changes this 1 to 0. So it changes the 1 to 0. And then over here, a NOT gate, it also converts the 1 to 0. Now this 0 is moving in this path and it's still moving in this path. So imagine if there was another line from this side to here, then this means the same 0 will still move upwards. Okay, so we would have 0 in this direction and then the same 0 in this direction. Now the input of this AND gate is 0 0, and for every AND gate we should get positive two positive input to get a positive result. So in this case we have 0 0, and that will give us 0. Okay, so this will give us 0. This is a NOT gate. So a NOT gate will convert this one to the opposite, and that we would have 1. So we still have our 0 coming from this direction. Okay, so we still have our 0 coming from this direction. Now this is OR gate and then a NOT gate, which is a NOR gate. So 1 0 will give us 1 for the OR gate. We said at least 1 supposed to be positive. So we have our 1 here. But when the same one gets to the NOT gate, it converts this one to 0. Then we have 1 1 giving us 0. So you have to take your time and analyze the question very well. Okay, understand the principles behind every logic gate and know how to apply them.